All right, couple reminders. Your vector assignments are due tomorrow. Okay, so make sure you have those ready for the start of class to hand in to me. If yours is done already and you want to hand it in, I'll take it. Your unit exam is on Monday. Okay, tomorrow will be our formal unit exam review day, where I'll kind of go over the test, give you what you can expect, okay, all of that kind of stuff. But obviously the review package is already up on Google Classroom for you to have a look at. Okay, tomorrow you'll just get kind of the details. And then I'll take any questions that you have from the entire unit. So it might not be a bad idea to have a quick look over things, and by quick I mean like 5-10 minutes, right? To figure out what things you may want to ask about tomorrow so that your questions get answered. Okay, if you have nothing tomorrow, then it's just what I think, and well, that might not be right for you. So if you come in with some specific questions, we can take care of that tomorrow as well. And Friday, we'll kind of see where we're at. If we're good with our projectile motion stuff, like on tomorrow's quiz, then we may start Unit 2 on Friday. Okay? We won't need to spend any more time on Unit 1. We'll definitely go over the vector assignment at the start of class on Friday, okay, so that you have all of the correct answers for that, so you can use it to study for your unit exam. All right, so that's kind of the plan going forward here. All right, so we now know how to do both types of projectile motion problems. We know how to do the projected horizontally ones, we know how to do the projected at an angle ones. So now it's just a matter of exposure to different kinds of, or different ways to word it, and different kind of sets of givens. So I would like you to have a look at, let's see, whoop, I can't write on that. Okay, let's say 5 through 8 for right now. Okay, questions 5 through 8. This is in your digital workbook, okay, and it is on page, starts at the bottom of page 9. Okay, so let's have you do 5 through 8 for right now. And obviously the answers are there, so you can see if you did it right or not, and then we can go through them. And then I'll probably then we'll watch maybe a quick video or something like that, then we'll do a few more and just make sure everybody gets what's going on here, because the first 2 questions, spoiler alert, on your unit exam are projectile motion questions. Okay? 1, projected horizontally. 2 would be projected at an angle. And, well, they're worth significant marks, so it's a good idea to know how to do. I can zoom it in, but you can also see it on your phone, but I'll make it a little bit bigger. Is that a little bit better? Okay, any other questions before we get started on those? Okay. Okay, so for number 5, which is not the page I'm on right now. That one is. Okay, so for number 5, we have an object thrown horizontally off the top of a cliff. Okay, at a velocity of 20 meters per second. Okay, the object takes 4.20 seconds to reach the ground. All right, there's a useful piece of information because it can go along with both the vertical and horizontal parts. Okay, time equals 4.20 seconds. Okay, time equals 4.20 seconds. And I also know that the horizontal velocity is 20 meters per second. How far from the base of the cliff did it hit the ground? Do I even need any of the vertical information here?
No.
No. What do I need to do?
D equals V times T.
Right, I just have to use V equals D over T, manipulated for D. Sometimes they're simple, and they're tricky when they're simple, because you think there's got to be more to it. Okay, and this is a prime example of that. All right, so 4.2 times 20 should be 84, yeah? 84 meters. Oh, it's right there. All right, everybody okay with that one? All right, how are we doing on number 6? Yeah? Do we want to go over number 6? Yes? Okay. All right, so for number 6, again, thrown horizontally off the top of an 85-meter tall building. So vertically speaking, I know the displacement is 85 meters. Okay, so we got 85-meter tall building. We know the acceleration is 9.81 meters per second squared, and it hits the ground 67.8 meters from the base of the cliff. All right, we're supposed to find how fast it was thrown. Okay, or the horizontal velocity it was thrown at. So, what's my initial vertical velocity?
0.
Okay, that, guys, is the thing we have to remember about horizontally projected projectiles. Okay, it is probably the most important thing we have to remember. Now that I have that, now I can use this. D equals VI times T plus 1/2 AT squared to solve for T, which I'm going to need to calculate horizontal V. All right, so T is going to equal the square root of D over half of A. So that'll be 85 divided by 1/2 times 9.81. Forgot to fire up my calculator. What are we getting for a time there, guys? 4.16. Okay. So we got 4.16 seconds. Okay, and now we can go V equals D over T. Okay, to get that. How often do we have to find time and use it on the other side? Almost every single time. I think we did like 2 questions where we didn't have to do that because they gave us the time. All right, so time is really important. All right, so we just take our 67.8, we divide it by our 4.16, and we've got that it was thrown at 16.3 meters per second. Because meters are not the units for velocity. Okay. All right, give you a little bit more time to work on 7 and 8, then we'll have a look at those. Okay, so on number 7, so this is our angled projectile question. So it's thrown into the air at an angle of 40 degrees above the horizontal at 18 meters per second. All right, so it's going to do this. The most important thing we need to remember about angled projectiles is that 18 meters per second is neither vertical nor is it horizontal. Okay? That it can be used to get both of those, but it should not go in either one of those categories. Okay? That is the mistake I see most often on a unit exam. So I'm going to be going through this question, it'll have VI, 18, V horizontal, 18. It's not. Okay? It's 40 degrees above the horizontal. It isn't either one of those. So we use trig to get those other numbers. Okay, so we are looking for how far it'll travel horizontally. So we break it up, vertical, horizontal, and we remember this, that this side of the triangle will be our initial vertical velocity, and that this side of our triangle will be our horizontal component of that velocity. Okay, so to get VI, we're going to go sine of 40 times 18 because it's the opposite side. Okay, so it's 11.57 meters per second, and it's up. Okay. Since they don't tell us otherwise, can we assume launch and impact are level? So what does that mean for VF? Negative. Okay, acceleration is negative 9.81 meters per second squared. All right, horizontally, we want to calculate the horizontal velocity, which is constant. It's the adjacent side of that triangle, so cos of 40 times 18. All right, so 13.79 meters per second, and I'm looking for the horizontal displacement. What do I need? as I always do, yeah. Okay, so I've got to find the time using my vertical information. All right, I can go like this and say A equals VF minus VI over T and just manipulate that for T. So that'll be negative 11.57 minus 11.57 divided by negative 9.81. All right, so in other words, it's going to be taking this number here and multiplying it by 2 and then dividing by 9.81. Except I did that wrong. Divided by 2. Divided by 9.81, sorry. Okay, so 2.36 seconds is our time. Okay, so that can come over to here. Okay, and now we can find out what D is. D equals V times T, so 13.79 times 2.36. All right, so we're looking at 30, actually we have, what, 2 significant digits in that question? 3, so 32 and a half then. Okay.
Could you just go through on this question, how to find the maximum height again?
Yeah, absolutely, we can go over that. All right, so if I wanted to find the maximum height for this question, okay, I would have to remember that that occurs right here, right smack in the middle of the flight in terms of horizontal distance and time, okay? So my time value is not going to be 2.36 anymore, it's going to be half of that, okay? So taking that number there and dividing it by 2 gives me the time, so 1.18. Okay, what's VF at this point? 0. Okay, and these are all vertical values, that's why they're in red. Okay, does VI change? Nope, this doesn't affect the beginning, it just affects the end. Okay, the end is now at halfway instead of all the way. So there's 2 ways to do this. Right? I could use this formula, VF squared equals VI squared plus 2AD. I'd be looking for D. Right? I have VI, I have VF at 0, and I have the acceleration. So if I manipulate that, it'll be VF squared minus VI squared over 2A. Okay, so that'll be 0 squared minus 11.57 squared, okay, divided by 2 times negative 9.81. All right, so that'd be one way to do it. If I did it that way, so 0 minus, and then that number. Squared, okay. And then divide that by negative 9.81. Sorry, 2 times 9.81. And I didn't do that right. I forgot to bracket that. Man, oh man, it's a struggle today. Okay, so it would reach a maximum height of 6.8 meters if I did it that way. Okay, I can do it another way, and that is that I can use that half of the time and use this formula instead. VI times T plus 1/2 AT squared. Okay, and so I would plug in 11.57 times 1.18 plus 1/2 times negative 9.81 times 1.18 squared. So far up now. Okay, times the 1.18 plus times negative 9.1 times radian squared. Okay, same number, 6.8. Okay, either way will work. See,
Which one do you find easier to use?
I find the first way easier to use because I always forget to divide time in half when I use the other one. And I find that that is a very common mistake for people solving it the other way. Okay, yes. Okay, how many people have done number 8? Okay, ready to go over that one then? Okay, so objects thrown into the air at an angle of 20 degrees above the horizontal at 15 meters per second. Okay, so that's what we know there. And it's going to do this, obviously. Okay, how far will it travel horizontally? So same as question number 7, basically. Okay, we just need to break this up into its vertical and horizontal parts. Okay, so VI, which will be that side, as it always is, will be the sine of 20 times 15. Okay, so 5.13 meters per second, and that's up. Okay, acceleration's negative 9.81 meters per second squared. VF is negative 5.13 meters per second. Okay, horizontally, same calculation, cos of 20 times 15. That is 14.10, well, 14.10, let's say, meters per second. Okay, we got to find our time again. All right, so time equals VF minus VI over A. So take that number again, multiply it by 2, divide it by 9.81. Okay, so we're in the air for 1.05 seconds. That's the only number that can go across. E equals V times T. We're looking at 14.7 meters horizontally. All right.
I have a question about so when you round it early, does it matter or is it okay just to keep it entire?
It is not okay to round it early.
Okay.
Always keep your digits until the very end.
You're just writing on the board.
Yeah, because I don't want to write 14.742835 or 08 every time. It just takes too long. So yeah, I round off on the board, but I always keep it in the calculator, and I always use that number that's in the calculator. Because, I mean, if we start doing a lot of other calculations, we're multiplying by a lot of numbers, that round off can have a big effect by the time we're done. So we always want to keep all of our decimals until the end. Now, on that note, good significant digit okay, is this. If I have a part A and a part B, say on an exam on, say, Monday, right? If I calculate an answer for a part A of a question and it has 3 significant digits, so I rounded it off, and then I need to use that number in part B, do I use its rounded significant digit value or do I use all the decimal points?
All of this means.
Nope, I use the rounded value. Good thing I asked that question. Okay, I use the rounded value because I have to reflect the accuracy of all the numbers I used to calculate it when it is a given in the next part of the question. Okay, so if you are carrying a number from a part A of a question to a part B of a question, you are using its rounded significant digit value. Okay, and it can sometimes make a difference. Sometimes it doesn't, but it can, so you should always do it that way. All right? Treat it like it's a given for another question, because part B is really another question. Okay, so we should be reflecting our accuracy properly that way. Okay. Okay, so there it is, 32 degrees declined, okay, like this. So when it gets projected off, it's going to be projected at an angle downwards. Okay, so this side is still V horizontal. This side is still VI vertical, but it's now going to be downwards. Okay, so instead of having a positive VI, you're now gonna have a negative VI. And are VF and VI equal anymore? They are not. Okay, that's only true if it's projected upwards and lands at the same height it's projected from, so now VF is also not equal to VI. So, in this one here, we know this is 22 meters per second, we know the angle, right? So we're gonna break it up again, vertical and horizontal. Okay, so we're gonna have, VI will be the sine of 32 times 22. Okay, so 11.66, but that's negative meters per second. A is negative 9.81 meters per second squared. Okay, and we know that the displacement there is going to be 9.0 meters. All right. Now we need the time. Okay. We also need V horizontal, which we don't have yet. Okay. So to get V horizontal, we're going to go cos of 32 times 22. Okay, so 18.66 meters per second. Now, here's the trick with this. I have VI and it's not 0, so I can't use this formula, which would have worked out nicely. Okay, because it's got all those things in it, but I told you never have to use it to solve for t if VI wasn't 0. Okay, so here's what I would do. I'd use this formula to get VF. Then I can use this formula to get time. Okay, so it's going to be kind of 2 steps. Okay. So if we do that, okay, we're going to have our 11.6 squared, okay, plus 2 times negative 9.81. Times negative 9, okay, because the 9 is also downwards. All right, now here's why we have to do that. I need to get a positive number here, because if I get a negative number, can I take the square root of it? Okay. All right, so I have to recognize that's not a positive number. VF is downwards, and it's going to be negative 17.68. Okay, so now that I've got that, now I can use A equals VF minus VI over T, so I'll take that number, and I'll subtract VI, which was that number. Okay, and then I will divide that by 9.81. Okay, so I get 0.61 seconds. All right, it's not going to take long for it to fall. Okay, that 9 meters. So 0.61 seconds. Now I can take that and multiply it by my horizontal velocity, which was that number there. Okay. 11 meters. All right. That one's a bit tricky. I probably wouldn't give you one like that on a unit exam, but it's worth doing. It's worth kind of seeing how something like that works. All right, tomorrow's quiz. One of each type of projectile motion question. Okay, one projected horizontally, one projected at an angle, just like the ones that will be on your test on Monday. Okay, so it will be good practice. I'll post that at 3:20 today as always. I'll see what I can do.
I'm just still a bit confused, like why the VI, it's negative here, but when you use it in the calculations, it can be positive.
Only because I'm using the squares, right?
The
When you
squares?
square a negative
Okay.
number, you get a positive
Yeah.
number. And I use negative and negative in there so that I would get a positive number. Because otherwise, if I don't, I
Yeah.
can't take the square root. Right? So I manipulated things to my
Yeah.
advantage.
Okay.
Yeah.